Good morning, students. Here we will discuss question number 12 of exercise 1.3. Your question is that f is a function from x to y, be an invertible function. Show that the inverse of f inverse is f. That is, f inverse of whole inverse is equal to f. Actually, in question number 11, we have done this question for finite set. Now it is for any set x and y. This result is true that you have to show. Previously, we have discussed in question number 11 that the result is true for the finite set ABC and 1 to 3. But here, we have to prove this result by taking an arbitrary element x and y. Here we will go to use one result, that is what? The inverse of a bijective function is a bijective function. Okay, inverse of a bijective function is a bijective function means if a function is 1, 1 and onto, its inverse is also 1, 1 and onto. So here you see it is given that f is an invertible function. F from x to y is an invertible function. So what? F from x to y is bijective. And since f from x to y is bijective, by this result we can say f inverse. F inverse will be a mapping from where? Y to x is also bijective, that I am written here. You just have to write down these things. F inverse from y to x is bijective. And again, since it is bijective, therefore it is invertible. Is not it? Again, you see your aim is to introduce F inverse whole inverse. So if F inverse is invertible, so again its inverse is invertible, bijective, right? So since F inverse is a bijection or bijective function, therefore F inverse whole inverse is also a bijective function. And F inverse whole inverse will be a function from where? From x to y. Now our aim is to, we see that this is bijective. Okay, that means f is bijective, f inverse is bijective, and f inverse whole inverse is also bijective. Now, to prove the result that f inverse whole inverse equal to f, we are taking an element x in the set x such that fx equal to y. That means y is an element in y. Now from here, if fx equal to y, we can write down y is equal to, x equal to f inverse of y, is not it? By definition of inverse function. We can write down what? X equal to f inverse of y by definition of inverse function. Again, if I use the definition of inverse function here, if I bring f inverse to the right side, it become what? Y is equal to f inverse of whole inverse of x. Again, by the definition of inverse function. Now, we know y, here you see, this is f inverse of whole inverse of x, that is equal to y. Now, in the place of y, we can write down fx. So, I am writing here fx. Then you see f inverse of whole inverse of x equal to fx. Then by equality of two functions, since x is an arbitrary element, we can write down what? F inverse of whole inverse is equal to f, this one. This is, since x is an arbitrary element, so f inverse of, and also f inverse of whole inverse is equal to fx for all x belongs to a. This gives you the conclusion that f inverse of whole inverse is equal to f. This completes the proof. Thank you.